What is node exactly? Node is a point where more than two branches are connected. Branches means wire, where more than two branches are connected. Okay, clear? Branches means the wire. Like suppose we are having, this one here. How many branches are connected? Three branches are connected. Similarly, we are having this one is also a node. Here four branches are connected. Okay, clear? Now I am drawing the diagram that is based on the nodal analysis. First of all, we have to see that how many are the number of nodes present in the circuit diagram. Clear? Like suppose this is the case. This is 5, 6, 7, 8, 10, 12, 14, 20. So what is our step number 1? Step number 1 is to determine the number of nodes, because how many are the number of nodes, then those are the variable, and those accordingly we have to make the equation. Like remember, mesh, for mesh analysis, yeah. uh, for mesh analysis, wait, wait, yeah, for mesh analysis we are having how many number of meshes, that would depends how many equations we have. So in this case we are having two nodes, right? Let us consider this one is node or not. Tell me, this one is node, so we can consider VA, that is node A, and the potential at A would be VA. Is this a node or not? 1, 2, 3. So this is B, and the potential over that would be VB. Okay. Now this is also the node because three wires are connecting over there, so we can consider the VC, and this is also the node, so it would be VD. Okay. So we have to consider the main node only. What are the main node? Because the down nodes will do it grounding, because at the grounding the potential is equal to 0. Why we have done grounding? To reduce the number of nodes, because if we'll take all the nodes then there will be 4 nodes total, and that would make a 4 equation, and to solve 4 equation that would be complicated for us, right? So as you can see that there is no element connected between D and C, correct? There is no element connected between D and C. So the potential at VD would be equal to the potential at VC, right? VD must be equal to the VC, so this node would be grounded. So at VD potential is also 0, at VC potential is also 0. Clear? Now step number 1 done. Next let's move to step number 2. In the step number 2 we have to mark current direction. Okay, current direction, that is accordingly will mark in the branches only, not in the loops as we did in the mesh analysis. We no, don't do it like this. We have to mark it along the path, like this is the path. Okay, now we don't mark it in the room. Suppose this one would be I1, this one would be I2, this one would be I3, this one would be I4, and this one would be I5. Randomly I have marked the current direction. You can mark according to your convenience also. Okay, step number 2 is also done. Let's move towards step number 3. What is step number 3? We have to apply KCL at node A. Okay, node A we have to apply KCL. What does KCL states? That KCL is the Kirchhoff current law. He states that sum of incoming current must be equal to the sum of outgoing current. Okay, sum of incoming current must be equal to the sum of outgoing current. So suppose this is the case. If I'll apply the KCL at node A, right, then how much, which current is entering into the node A? Tell me. Yeah, I1 is entering, and which current is leaving the node? Yeah, I2 and I3. So can I write down I1 is equal to I2 plus I3, right? Similarly, tell me for that at node B, how much is the current? I3 is equal to I4 plus I5. Yeah, I3 is equal to I4 plus I5. Got it? Our next step is also completed. Now the next step number 4, we have to calculate current according to Ohm's law. As you know, according to Ohm's law, I is equal to V by R, right? So I1 we are writing down. As you can see, I1 is moving from which node to which node? Like just imagine this is your home, okay, and this is your college. So I1 is moving from home to college, correct? So from wherever you are leaving, that would be positive, and wherever you are entering, that would be negative. And whatever the second sign of the battery comes in your path, you have to take the second sign. Okay, like suppose I1 is you and you are moving from home to college. So at home the potential is 0, you are moving towards college, so that would be negative way, because current is moving from higher to lower. Higher the sign positive and the lower the sign negative. Okay, and in between his path there is a battery over there, and we have to take the second sign of the battery. So tell me, what is the second sign of the battery? Negative or positive? Positive. So plus 20 divided by the resistance comes in his path, that is how much? 5 ohm. Okay, now similarly I2 is moving from college to home, right? So we can say that I2 would be VA minus 0 divided by 6, correct? Plus I3. I3 is moving from college to, suppose VB is like you are after college, you are going for a gym. You are moving from college to gym, I3, right? So it would be how much? VA minus VB divided by the resistance, that is 7 ohm. Okay, got it? Similarly, we need to convert this I3 in terms of V by R. I3 is again moving from VA to VB, so it would be how much? VA minus VB divided by the 7. And I4 is moving from gym to home, so it would be VB minus 0, and there is a second sign of the battery, that is minus 10 divided by 8, plus again I5 is moving from VB to 0, so it would be VB minus 0, again the second sign of the battery, minus 14 divided by the resistance. Okay, clear? Okay, but now why? Sorry, over there in the corner for I5, why is it VB minus 0? Minus 14. Minus 14 is also there now. And why is the minus 14 in the fraction? It should be separate. No, it is not in the fraction. The I5 value is VB minus 0 minus 14 divided by 12. Okay. Now you are having two variable and two equation, right? You can solve it through calculator, then you will get the value of VA and VB. Got it?